Okay, this video is going to be on derivatives of inverse functions. The first thing we have to do is remember what it means to be an inverse function. So for instance, if f of x equals 2x squared plus 5x, then the inverse function, we would plug in y, and we would switch x and y and solve for y. Now I'm not going to do that, but you should remember that that's what you do. You should also remember that when you compose, let's call f inverse of x, we'll call it g of x. When you compose a function and its inverse, you always get x. That's how you know if something's an inverse of something else. When you plug it into itself, you should get x back out. We should also remember that the domain of the original function is the range of the inverse, and the output of the original function is the domain of its inverse. The domain and range get switched for a function and its inverse. So how do we take the derivative of an inverse function? Well, let's think about this right here. If we want to take the derivative of both sides, we would say, take the derivative of the outside, leave the inside alone, times the derivative of the inside. And that equals 1. That's just the chain rule. But we want to know what's the derivative of the inverse. Well, this is the derivative of the inverse, because remember we said that g was the inverse. So if we solve this equation for g prime of x, we get 1 over f prime g of x. You can choose to memorize this, or you can choose to derive it every time you do it. I suggest deriving it so that you don't mess up, because there's lots of these little derivative symbols. Hopefully it makes sense to you where this came from. So for instance, here's a problem. G is the inverse of f. F of x is x cubed plus 2x. Find g prime of 3. So that means we want to find the derivative of the inverse of f of x at the point where x is 3. Well, the first thing we can find is f prime of x. That's pretty easy. And we can also find f prime of 3 by just plugging 3 in there and getting 29. What we don't know, however, is g of 3. And if you look back at our formula, we have to take f prime of g of 3. How do we know what g of 3 is? In other words, how do we know what the value of the inverse is when the input is 3? Well, the input to the inverse is the output of the original function. So we want to know, when did this equal 3? So we go to our trusty calculator, and you're going to put x cubed plus 2x into y1 and 3 into y2, and you're going to find that when x equals 1, the output is 3. So another way of saying it, f of 1 is 3. That means that the inverse, f inverse of 3, is 1. Domain and range switch for the inverse. Okay, well remember in this problem, f inverse is called g. So g of 3 equals 1. Now I realize that's a lot, but hopefully you understand where it comes from. I looked at the original function, and I found when its output was 3. And that was my input. So input, output of the original function, they switch around and you get input, output of the inverse. So back up to our formula. G prime of 3, we want to find G prime of 3 equals 1 over f prime of g of 3, which we said was 1. So f prime of 1. G prime of 3, 1 over f prime of 1. Plug it in. Oh, don't plug it in there. Plug it in here to the derivative, f prime. And you get 5. There's your answer. G prime of 3 is 1/5. Again, I know it's a lot. Hope it makes sense. Now I could show you where all of these derivative of trig functions come from based on what we just did, but I think that you will cry, and I think it's a lot. So I'm just going to tell you that you need to memorize 3 more derivatives. Memorize, like not just try to recall. You should have, forget about this stuff for right now. All of these should be ingrained in your brain. Already you have these 6 memorized, hopefully. Now you need to memorize these 3. And I'm going to show you how to use them right now, but you need to memorize them. And I'm going to give you this paper in class, but put these somewhere that you can study them and memorize them and understand them. So let's try a few problems. The first one I want to try is y equals inverse sine of 2x cubed. Okay, so back to our little formula sheet. The derivative d dx of sine, arc sine, remember this does not mean 1 over sine, this means arc sine, the angle whose sine is, of x is 1 over square root of 1 minus x squared. But remember the chain rule, if x is not just plain x, you have to multiply by the derivative of the inside. So for this problem, y prime is going to be 1 over the square root of 1 minus 2x cubed squared times the derivative of this, 6x squared. And if we simplify that, this squared is 4x to the 6th. 1 minus 4x to the 6th times 6x squared. Can we simplify that? I think we can probably just leave it like that. Let's see what the answer says. 6x squared over square root of 1 minus 4x to the 6th. Perfect. Okay. That's sine. Now let's do one that's cosine. Y equals inverse cosine of 2x to the 4th. Inverse cosine 2x to the 4th. Well, my handy dandy cheat sheet tells me that dy dx is negative 1 over square root of 1 minus x squared. But again, in this case, x is 2x to the 4th. So dy dx is negative 1 over the square root of 1 minus 2x to the 4th squared times derivative of the inside, 8x cubed. Final answer, negative 8x cubed over square root of 1 minus 4x to the 8th. Let's see what the handy dandy answer says. Negative 8x cubed over the square root of 1 minus 4x to the 8th. Perfect. Last one. We're going to do a tangent one. Y equals inverse tangent of negative 5x to the 4th. So the formula says that the derivative of arctangent, or inverse tangent, is 1 over 1 plus x squared. So dy dx equals 1 over 1 plus negative 5x to the 4th squared times negative 20x cubed. Simplified, negative 20x cubed over 1 plus 25x to the 8th. And that is all. Those are all 3. Just remember to do the chain rule and memorize those derivatives.